method for generating a complete Sudoku puzzle is relatively simple. First, start with an empty 9x9 array. The goal is to create a Sudoku board cell by cell. Starting with the first cell, the code first generates a random integer between 1 and 9. It then checks if the number is already present in the row, or the column, or the 3x3 block the cell occupies. The code iterates this process through all 81 cells in the array to create a complete Sudoku board. Unfortunately, using this method, the code will run into situations where it is impossible to put any integer into the next cell without violating one of the Sudoku rules. Therefore, every time the code runs into an unsolvable situation, it erases the array and restarts the process from the first cell until it creates a full Sudoku board.
My name is Yumi, and this is the code for removing numbers from the completed puzzle. I first create an empty array that's going to hold the puzzle for the user to solve. It then enters a for loop that repeats 9 times, one for each row in the puzzle. In this number remover, the numbers that are removed are identified with a 0. For each row, it generates a random integer between 1 and 8. This is the number of numbers that the program will delete from the row. It then generates another random integer between 1 and 9. This is the index of the number within the row that will be deleted. If the number has already been deleted, the program moves on to the next number in the row. If the number 9 was chosen and already contains a 0, it goes back to the first index. This check is repeated 3 times. Once it completes the check, the number is then set to 0. After it completes moving the numbers from the row, it appends the new row to the array for the user to solve.
After generating a Sudoku puzzle by removing elements from the complete array, the code checks if the puzzle is solvable. To do this, it utilizes the Sudoku solver function provided in the outline and counts the number of solutions possible for the recently generated Sudoku puzzle. For the sake of simplicity, if there is more than one solution, our code deems the puzzle unsolvable.
My name is Hannah Chang, and I will be discussing the GUI window code. The GUI window is for the user so that the user is able to interact with the program, which is the Sudoku, so they are able to fill it out. So this the actual grid, the Sudoku grid, consists of 81 text boxes, which are positioned appropriately to create the typical image of a Sudoku puzzle. Each box is specifically positioned by using a double for loop, which evenly increments the position of each box. It also spaces the 3x3 blocks apart after the double for loop, and this is all in front of a black background, which allows it to have more of the defined lines. Another for loop is used to create each individual text box. The EVA function is used because it defines each text box to a separate global variable. The generate button creates a completed Sudoku board and starts by using a for loop that creates an array defining each 3x3 block. It creates a matrix B and arranges it so it organizes all the numbers in numerical order. Another for loop is used which finds the indices for all the cells with certain numbers in them. We use correct_Sudoku as a global variable so that all the functions are able to utilize it. Inside, there is a for loop that modifies each text box to match the new puzzle. We also see there's also the done button, which again retrieves the Sudoku solution to the global variable and compares each square by using the is_equal function, and this is all in one. So there we have it. This is how we made our Sudoku puzzle. Happy solving!